The sunlight hitting your face right now left the sun 8 minutes and 20 seconds ago. Not almost now, not recently, 8 minutes. That means the sun you're looking at doesn't exist anymore. The sun you see is a photograph from 8 minutes in the past. And by the time you finish reading this sentence, the real sun will have changed in ways you'll never directly witness. Most people hear this fact and nod. They get it intellectually, but they don't actually sit with what it means. Because what it means is that you have never in your entire life seen the sun as it actually is right now. You have never seen the real present moment of anything outside your immediate proximity. And that fact changes everything about how you understand reality, time, light, and what it means to see. Let me back up and explain how we know this is true, because the number 8 minutes and 20 seconds isn't arbitrary. It's the result of a simple calculation. The sun is 93 million miles away from Earth. Light travels at roughly 186,000 miles per second. 93 million divided by 186,000 equals about 500 seconds. 500 seconds is 8 minutes and 20 seconds. That's it. That's the math. It's not a theory. It's not approximate. It's as close to a fact as physics gets. But here's what makes this strange. When you look at the sun in the sky, it doesn't feel like you're looking at something 8 minutes old. It feels immediate. It feels present. Your brain isn't calculating the delay. It's not saying to you, I'm now processing light that left the sun in the past. It just feels like you're seeing the sun right now. And that feeling is lying to you in a very specific and important way. The reason your brain creates that illusion of immediacy is because your brain has no choice. Your visual system didn't evolve to handle the concept of light delay over cosmic distances. For most of human history, for most distances, we actually cared about light seemed instantaneous. You look at a person across a room and the delay between when light leaves their face and when it reaches your eye is something like 1 nanosecond. 1 billionth of a second. Your brain can't detect that. So your brain learned to treat sight as immediate, to treat what you see as what is. But the sun broke that assumption. The sun is far enough away that the delay becomes noticeable if you do the math. And once you know the math, you can't unsee it. Here's what happens when you look at the sun, if we're being precise. Photons, particles of light, leave the sun's surface. They've been created through nuclear fusion in the sun's core, where hydrogen atoms are being fused into helium at temperatures around 27 million degrees Fahrenheit. These photons start their journey toward Earth. The sun is emitting light in all directions, so the vast majority of these photons never reach Earth. They go off into space, but the ones pointed roughly in our direction begin their 8-minute journey. As they travel, they're traveling through what is essentially a vacuum. Space has some dust and some gas, but it's mostly empty. The photons move at the speed of light, which is the fastest anything can move. They don't slow down, they don't speed up. They just move at exactly 299,792 kilometers per second. This speed is a constant in the universe. Einstein discovered that nothing can go faster than light, and that light always travels at this same speed regardless of where you measure it or how fast you're moving relative to it. It's one of the strangest facts in physics, and it's also one of the most certain. So the photons move at this constant speed for 8 minutes and 20 seconds. And then some of them, a tiny fraction, roughly 1 photon per square centimeter per second, when you account for the sun's total output, hit your eye. They hit your retina. Your retina is covered in cells called photoreceptors. These cells contain molecules called rhodopsin that actually change shape when they're hit by a photon. That shape change triggers a chemical cascade that eventually generates an electrical signal. That signal travels up your optic nerve into your brain, and your brain processes it and creates the experience of seeing the sun. But here's the crucial part. By the time that signal reaches your brain, the actual sun, the real, present sun, is 8 minutes and 20 seconds older than the sun that emitted the light you're now seeing. The real sun has rotated. Its surface has changed. Sunspots have appeared and disappeared. Solar flares have erupted. And none of that is visible to you in this moment. Now, you might be thinking, okay, so what? The sun doesn't change that much in 8 minutes. And you're right. The sun is stable enough that 8 minutes doesn't make an enormous visible difference. But that's not really the point. The point is about what it means for you to see. The point is that seeing is not direct access to the present. Seeing is receiving ancient information encoded in light. This becomes much more obvious when you think about the stars. The nearest star to Earth, besides the sun, is Proxima Centauri. Light from Proxima Centauri takes 4.3 years to reach us. When you look at Proxima Centauri on a clear night, you are looking at light that left that star 4.3 years ago. You are looking at the star as it was in the past. If Proxima Centauri exploded tomorrow, you wouldn't see that explosion for 4.3 years. For 4.3 years, the star would still look fine to you because the light showing you an intact star would still be traveling through space toward your eye. Astronomers actually use this all the time. They look at distant galaxies and they're seeing them as they were billions of years ago. When they look at a galaxy that's 13 billion light years away, they're seeing light that has traveled for 13 billion years. They're seeing the universe as it was 13 billion years in the past. And this isn't a limitation of their telescopes. This is built into the structure of reality. The only way to see something distant is to receive light that has traveled from that thing to your eye. And light takes time to travel. So in one sense, your entire visual experience of the universe is out of date. Everything you see is old. The closest thing you can get to seeing the present is things that are right in front of you. And even then, there's a delay. Light from your hand to your eye takes a few nanoseconds. Your brain processes that signal. And by the time you're consciously aware of seeing your hand, another 100 milliseconds or so has passed. So you're actually seeing your hand as it was a tenth of a second ago. You've never actually seen your own hand in the present moment. This is not just a quirk of how eyes work. This is built into the fundamental nature of reality. This is relativity. Einstein figured out that space and time are not separate things. They're woven together into something called space-time. And the speed of light is the maximum speed at which information can travel through space-time. Light is the fastest messenger the universe has. Everything else is slower. And that means that everything else is even more out of date. Think about what happens when you have a conversation with someone across a table. Sound waves travel from their mouth to your ear. Sound moves at about 1,100 feet per second. That's much slower than light. So there's a delay. You see their lips move first, and then you hear the sound. But the delay is small enough that your brain corrects for it automatically. You experience the sound as synchronized with the mouth movement, even though it technically arrives later. But there's a subtler version of this happening constantly. The neuroscientists have measured this. When light hits your retina and starts the process of creating vision, your brain actually processes that information for about 80 to 100 milliseconds before you become consciously aware of it. During that time, the world outside has changed. The object you're looking at has moved, but your brain is making predictions about where things will be and what they'll look like. Your conscious perception is actually slightly in the future. Your brain is guessing about the present. This is called predictive coding. Your brain isn't just passively receiving information about the present. It's actively predicting what the present should look like based on past patterns. And then it compares that prediction to what the sensors are telling it. When there's a mismatch, that's when you notice something has changed. It's remarkable, actually. Your sense of the present is not the present at all. It's your brain's best guess about the present based on delayed sensory information. But let's come back to the sun. The 8-minute delay of sunlight is particularly interesting because it creates a kind of philosophical problem. Let me describe a scenario that physicists sometimes use to think about this. Imagine you're on Earth and you see the sun in the sky. And imagine that at the exact moment you see that sunlight arriving at your eye, something catastrophic happens. A massive solar flare explodes from the sun. The sun expands, it engulfs Mercury, it engulfs Venus. It gets close to Earth. You're about to be destroyed, but you don't know it yet because the light's showing you the new sun, the expanded sun, the dangerous sun, won't reach you for another 8 minutes and 20 seconds. So for those 8 minutes, you continue to see the old sun in the sky. The sun you see is peaceful. It's the sun from 8 minutes ago. You're completely unaware that you're about to die. The real present sun is already bearing down on you, but you haven't seen it yet. You won't see it until it's too late. You've already been destroyed by the time the first photons of the new sun reach your eye. This is not a realistic scenario. The sun doesn't expand that fast, and it's not going to destroy Earth anytime soon. But it illustrates something profound. Your visual access to reality is not immediate. There's a lag, there's a delay, and depending on distance, that delay can be long enough to matter. It can matter enough that you don't see danger coming. Now, there's something even stranger about this, and it has to do with what physicists call the relativity of simultaneity. Here's how it works. You're on Earth and you see the sun in the sky. Someone on Venus is also looking at the sun. Light takes about 3 minutes and 10 seconds to travel from the sun to Venus. So someone on Venus is seeing the sun as it was 3 minutes and 10 seconds ago. And you're seeing the sun as it was 8 minutes and 20 seconds ago. So here's the question. Which sun is real? The sun as it appears to the person on Venus? The sun as it appears to you? Or the sun as it actually is right now? The answer, according to relativity, is that there is no absolute right now. There's no absolute present moment that all observers in the universe agree on. The present moment is relative. It depends on where you are and how fast you're moving. An observer on Venus has a different now than you do. An observer on Jupiter has an even different now. And none of them is more correct than the others. This is one of the deepest insights of Einstein's theory of special relativity. Time is not a single universal flow that everyone experiences the same way. Time is woven into space-time, and different observers can disagree about the order of events, about the duration of events, and about what counts as happening right now. The reason this matters for the sun is that it means there is no single objective fact about what the sun is doing at this moment. There's only what the sun appears to be doing from your location. And that appearance is a message 8 minutes old. So when you feel the warmth of sunlight on your face, and this is the part that really gets me, that warmth is also 8 minutes old. The heat you're feeling was emitted from the sun 8 minutes and 20 seconds ago. The photons carrying that energy traveled through the vacuum of space at the speed of light. And when they hit your skin, they transferred their energy. The sensation of warmth is real and present. But it's caused by ancient photons. In a way, the sun is always behind us. It's always in the past, and we're always living in a universe that's slightly older than we perceive it to be. We're always one step behind reality, or maybe more accurately, there is no such thing as a single unified reality that we're behind. There's only the universe as it appears from where we are. And that appearance is always delayed by the time it takes light to reach us. Here's something I find genuinely unsettling about this. It means that the sun you see could have ceased to exist sometime between now and 8 minutes ago. And you would have no way of knowing. The sun could have gone out like a candle. It could have been destroyed. It could have been transformed into something else entirely. And you would continue to see the old sun in the sky for the next 8 minutes. You would see a sun that was already dead. In fact, there's a version of this that actually happened in the history of astronomy. In 1604, a star called Kepler's supernova exploded. Astronomers on Earth saw it suddenly appear in the sky as a bright new star. But that star hadn't just exploded. It had exploded 8 years earlier. The explosion had happened in the year 1596. For 8 years, the light from that explosion was traveling through space. And then in 1604, the light finally arrived, and astronomers got to witness a cataclysm that had actually taken place before some of them were born. So in a real sense, we're always living in a cosmos that's older than we think it is. We're always seeing events that happened in the past, no matter how far or how close. And this is not a limitation of our technology or our perception. This is a fundamental feature of how reality works. Now, you might ask why this matters. Why should you care that the sunlight on your face is 8 minutes old? It's not like you can do anything about it. It's not like knowing this changes how you live your life. And that's true in a practical sense. The sun is stable enough that you don't need to worry about it changing dramatically in 8 minutes. But there's a deeper reason it matters. It matters because it reveals something about what seeing actually is. Seeing is not direct perception of reality. Seeing is the reception of ancient information. It's a message from the past encoded in light. When you look at anything, you're not looking at the thing itself. You're looking at a photograph of the thing, a photograph made of light. And that photograph was taken in the past. This is worth sitting with because it contradicts how we naturally think about sight. We think of eyes as windows to the world. We think of sight as giving us direct access to what's really out there. But that's not accurate. Sight is mediated by light travel time. It's always one step removed from the actual thing. The actual thing is always slightly beyond your reach, always slightly in the future relative to what you perceive. There's a philosopher called David Hume who argued that we never directly perceive objects. We only perceive impressions, sensations, ideas. Hume thought this was a problem for our knowledge of the external world. But the physics of light travel time gives his argument a concrete scientific basis. You really don't perceive objects directly. You perceive photons that have traveled from objects. The objects themselves are always out of reach. This becomes clearer when you think about trying to coordinate actions across distance. Imagine you and a friend are standing on opposite sides of Earth. You both want to turn on a light at exactly the same moment. But light from your side to their side takes about 1/10 of a second to travel. So if you both look at a clock and try to turn on the lights when the clock reaches a certain time, you'll think you've synchronized perfectly. But from the perspective of someone watching from far away in space, the lights will blink on at different times. This is not just a quirk of how clocks work. Einstein proved that there is no such thing as absolute simultaneity. Two events can appear to happen at the same time to one observer and at different times to another observer, and neither observer is wrong. They're just in different reference frames. And the reason this happens is because light takes time to travel. Information takes time to propagate. And the universe doesn't care whether we think two things happened at the same time. The universe just cares about cause and effect, about which event could have caused which other event. So when you look at the sun, and think you're seeing it as it is right now, you're participating in a kind of useful illusion. You're ignoring the light travel time. You're pretending that the photons reached your eye instantaneously. And in practical terms, for the sun, this works fine, but it's not actually accurate. The sun you see is a ghost. It's a phantom from 8 minutes in the past. And that means that everything you see is a ghost in the same way. Your friend's face is a ghost from a few nanoseconds in the past. A distant building is a ghost from a microsecond in the past. A star in the night sky is a ghost from light years in the past. You are entirely surrounded by ghosts. Your entire visual experience of the world is an experience of old things, ancient information, messages from the past. But here's the thing, that's not a problem. That's not a failure of perception. That's reality. That's how existence actually works. And once you understand that, once you really grasp it, it changes how you think about the nature of time and presence. Because if the past is constantly arriving at you in the form of light, then the past is not gone. The past is still here. The photons from the past are still traveling through space, still reaching your eyes. And the future is something you can't see yet because the light from the future hasn't reached you. The present moment is this razor-thin edge where new photons are arriving and being processed, where new information from the past is becoming part of your experience. In that sense, the past is not past at all. It's still happening, it's still arriving, it's still shaping your perception of reality. And the only reason you call it the past is because it happened somewhere else, somewhere distant. But the universe doesn't have a single clock. There is no universal now. There are only different observers in different locations, each with their own sense of present based on when information reaches them. So the sunlight on your face is 8 minutes old. And that simple fact opens up a view of reality where time and space are not what they seem, where seeing is not what we naturally think it is, and where every moment of your existence is composed of light from the past. The sun you see is a sun that no longer exists, but it's still real. It's still there. It's still touching you. And that makes you wonder what ancient light is hitting you right now. What messages from the past are reaching your eyes and your skin and every sensory receptor in your body? You are being constantly bombarded by ancient light. You're constantly being touched by a universe that's slightly older than you perceive. And there's nothing you can do about it. There's nothing you can do except understand it, sit with it, and let it change how you think about what's real.